Welcome everyone to the What's New webinar for ioGAS version 7.3, which is available now. It's up on our website, so if you're an existing user, of course, you can just download it, install it, and get going with it. So on the line, obviously there's myself, Dave Lowy, and also Putra Sadikan, and also lurking in the background is Sophie Alexander. So I'm sure that all of you will have at some stage had some contact with Putra and Sophie. I'm really here just to introduce it and make some commentary. Putra is really the star of the show. He's going to take you through the use of the software, the new features especially, in quite some detail. So if you go to the overview, Putra.
Yep.
Thank you. So what we'll do is I'll just run through the major features just quickly, and then Putra is going to show you a video, a quick video that he made that illustrates how to operate the new features. But then after the video, we'll go live, and then we'll be able to go through some of the new features more slowly. And Putra will be running GAS to illustrate how they operate. And if you have any questions on the way through there, then feel free to pop them into the chat window, and I'll be able to answer them while Putra's operating GAS. And then we'll just wrap up at the end, and you can ask some more questions there if you like. After this session will be recorded. So if you have other people in your organisations that you think would like to see this video, they'll have access to it via the IMDEX website. So just to cherry pick some of the new features here before you see them, just to give you a little bit of context around them. On the major features list there, we've got the highlight. There's a new highlight selection tool. You could call this a flash highlight selection. That's how we started. That's how we implemented it initially, but actually we jazzed it up a little bit, so it does operate as a flash highlight, but you can also convert the flash highlighting to a permanent selection in GAS if you think what you're highlighting temporarily is interesting. As usual, we've expanded the provided resources, so there's always some new calculations and diagrams and you can get released. For those of you who are Python users, there's a beta Python link built into this version of GAS, which we won't go into in this demonstration online, but it's documented in the help file. And while I'm at it, always look at the help file if you have an initial question. All of these new features are well described in there. But if you would like to use the Python beta link and you have feedback, please send it to us. We're very interested in what you think of it and where we should take it next. The other feature, new engagement. Yeah. It's got some feedback there. It's gone. It's gone. Is that you, Putra? The other new feature in GAS is the QGIS live link, which is operational. It works. We only say it's in beta because we can release the QGIS live link asymmetrically with the ioGAS releases. So it's out and it's operational, and you'll see it during this demonstration. But we are continuing to add features to it, so there will be more releases of the QGIS live link between this release of GAS and the next release of GAS. So again, if you have feedback, if you're using it and you have feedback, please send it to us because we can look at it virtually in real time. One of the things which is impressive enough as it is, but one of the things that's not in the live link currently is the ability to make a selection in QGIS and send that back into GAS live. That'll be coming up in the next version. But please, if you're a QGIS user, have a go with this link and see what you think. There's a new variable map batch export tool that's helpful for getting the ranked variable maps into GIS software. It will work with the typical GIS software platforms that you use now, but it's especially useful with QGIS because if you're looking at a bunch of ranked variable maps and you make the batch export in QGIS, you can do a multi-select and bring them all into QGIS in one step. There's a new clustering algorithm, dbScan, which is available in the self-organizing maps tool, but also standalone. Something called a recurrence plot, which again, we will show you in the demo, but if you go to the help file, you can read about what it's about. A way to think of that is it's like a multivariate extension of the Wavelet tessellation. So it looks for boundaries, and in our case, hopefully alteration, geological boundaries of some sort by taking into account more than one variable at a time. And another thing which we've had on our minds for a long time here are the enhanced QQ plot, quantile plot options. So one of the new bits of functionality around that, which you'll find useful, is if you have gold 1, gold 2, assayed 2 different ways, or just you're trying to compare 2 different assays, and you have different analytical methods as an attribute, you can make QQ of those 2 columns, QQ plots of those 2 columns by that attribute. And if that attribute is a lab method or different labs, it'll just produce all those QQ plots in one step. Something we've been asked for a lot, the fold axial plane estimator for stereo nets, and some other improvements in there as well, which are all in the help file, all described in the new release notes. Just the last comment I want to make there is we increased the number of supported columns to 512. And what's driving that from talking to people is people bringing in data from AI Siri, which is now part of the IMDEX group, as most of you will know. So people trying to join a lot of the scalar quantities that come out of AI Siri against geochem and other data. We were hitting our limit of columns, so we've expanded that, and we figure that should keep people happy for the next bit of foreseeable future, at least anyway. So now I'm going to hand back to Pooja, and he's going to show you the video he made, and then when that's finished, we'll come back online live and go through some of the new features in real time. Thanks, Pooja.
Thanks, Dave. So I'll just show the what's new video that I've recorded, and let us know if you can't see it. I'm just going to play it now.
Thanks, Pooja. Are you going to put your screen back on? Yeah.
Yep.
So that was the quick run through. And like I said, these videos will be up on our website after this webinar for those that weren't able to make this event. But now it's going to hand over to Pooja. He's going to run GAS live and just go through, so not all of them, but some of those features. And please feel free to ask questions on the way through. And I'll be able to answer them, or Sophie might be able to jump in and answer them while Pooja's busy running GAS. So over to you, Pooja.
Thanks, Dave. So we'll start off with the Flash Highlighter tool. So that's one of my favorite new tools in GAS because it's a really quick and easy way to sort of highlight some of the patterns that you will find interesting in any of the plots that you have open. So say I've selected gold in this data set and I create a probability plot. So the usual workflow in GAS is you would create a new attribute group to assign them to samples that you find interesting. But with the Flash Highlighter, what you can do is you can select that from the right-hand side toolbar, and you can select the data points using the tool. So select the points that you find interesting, and you can see them being reflected in here. So you can see them being reflected as that yellow highlight around those points. So another thing that we can do with this is you can reverse the order. So that's one that I didn't show in that video. But if you click on this button and below that, you can invert the selection. So you can basically choose it to display everything but the highest values within the gold probability plot, for example. And as Dave mentioned, you can apply that attributes to a selection. So if I invert that again, and if I apply that attribute to a new color group, I can choose to do that as well. So if you're happy with a selection, you can choose to make that permanent. And of course, the Flash Highlighter tool is also applicable in every other open plot that you have open in GAS. So for example, if I choose to highlight these points here, and if I open things like a scatter plot and a splum and a histogram, it actually gets reflected in all of the other open plots that I get open at the same time. So yeah, so it's retained within that moment, and it's also retained within any of the open plots that you'll open subsequently in time within the same workspace. So that's the Flash Highlighter tool. And while we're on this data set, I'm going to show the QGIS live link. So this one's pretty cool in that you'll be able to pretty much do your visual attribution of data points in GAS and have that being reflected in real time within QGIS environment. So I'm just going to minimize this and then have QGIS open at the same time. So the live link itself is only compatible with ioGAS 7.3 and the latest version of the plugin. So if you go to our website, you will need to download both 7.3 and the 7.3 plugin version of the QGIS plugin. And you can access that from this menu here. So it actually says live link. So what you can do now is click this, and that should be reflected in real time within within QGIS as well. So you can see that's the color group that I created, with the orange, and which is created from that gold probability plot. So what I can do now is say I'm interested in these points, right? So I've highlighted them using the Flash Highlighter tool, and I can assign them as a new color group as well. So instead of this, I'm just gonna create a new color group and assign that to that. And then you can see that being reflected automatically in QGIS. And obviously the application of this is limitless, because what you can do is you can do something like this. So you can create, say, classification plot. So say using a Jensen cation plot, for example. So it's a pretty straightforward application, and you just assign color attribute to where it sits in the polygon, and you have that reflected in QGIS. And the best thing about this is all of the information within the ioGAS workspace is reflected in real time in the QGIS attribute table as well. So what I'm trying to say is, if you create a new column based on the color grouping here, it's also going to be reflected in QGIS under the attribute table. So that's one way to make this permanent. And also what you can do is you can choose to save this layer in QGIS itself to make it a part of your workspace in that Q environment. So that's a QGIS sort of live link overview. And what I'm going to show you now is the variable map batch export, which may be a feature that gets overlooked at if you don't look at the plugin in detail. So what I'm going to do now, so I'm going to run just a couple of elements. So I'm just going to select, say, maybe gold.
There you go, Putra. QGIS just caught up with you.
Yes, right. GAS is faster than QGIS. There you go.
So that is one of the things we're working on. That's why the link is in beta. It works, but one of the things we're looking at is optimization of it now to speed up the comms between the two bits of software.
Yep. So watch that space. So what I'm going to do now is I'm going to select, say, some Chalco file elements, and I'm going to create some variable maps, right? So this is a workflow that some of you would be familiar with. So say you want to export these elements from variable map into separate thematic layers. And at the moment, what you would have to do is, you can go to Attribute Manager and do the attribution manually, export them one at a time using attribute map and export as a tab file or as a GAS file and import to QGIS. But now we make the process super quick. So on the right-hand side toolbar of a variable map, you have this option called export visible rows to multiple GAS files. So the way a variable map is set up is a bit different, right? Because there's no attribute manager setting that sort of replicates that. So what we came up with is a workaround that sort of transposed that into an attribute manager color and size schemes. So I'll show you what I mean. So I'm just going to export this into a series of GAS files, and basically what it will do. So I have 5 elements selected here, right? So it's going to export 5 separate .gas files, and then I'm going to open them. I'm just going to open one first in ioGAS, and I'm going to show you what each one looks like. There's just one more. So basically what it does in the background is it looks at each one and it exports each one as a GAS file. That's why it's taking a bit while. So I'm going to bring up one of the files that I exported. So you see that it generated 5 files, right, for each of the 5 elements that I generated. So I'm just going to open one. So say I'm going to open the copper exported variable map. And then you can see here, basically what it does is it looks at the variable map sort of thematic, and then it tracks them into the bins within the attribute manager color and size. And what you can do with this is, I'm just going to bring it up as an attribute map just to show you what I mean. So that's the equivalent of what I exported from the variable map. And then in QGIS itself, I'm going to click on Scratch Layer. And what you can do now is, I'm just going to, see in a sec, just going to find So what I can do now is I can select multiple files. So you couldn't do this before, but now I can do that. So you can click and drag multiple files. I'm going to select 5 of them, but it might take a while. So I'm just going to select maybe 2. So gold and arsenic. So I'm going to select 2 and click on open. I'm just going to let it run. So basically it brings in both at the same time. So you got your thematics right there. Click export in one click and import in one click, and it's just very quick workflow. So that's all in QGIS land. So I'm going to move back onto GAS now, and I'm going to look at some examples. Yep.
I've just got a question here from Chris Ben. He's just asking if we're going to offer multivariate wavelet tessellation. Yeah, that's on the books for the next version of GAS, Chris. But in the meantime, the recurrence plot is similar but different, if that makes sense.
Yep, and we'll show the recurrence plot in a bit, because you can essentially do a form of that workflow, but not exactly multivariate wavelet. But yeah, it does tell the same story. So this is another improvement that we've added to QQ plot. So it's a bit of a shortcut that I've already got this opened up before. But it basically allows you to open multiple QQ plots at the same time. So you got this, and then, and whereas before it opens one at a time. So now you can do this. And another way that you can show how the new QQ plot by attribute sort of works is in the ioGAS demo dataset. You know that there's a column here called sample medium. And basically what we can do now is we can select, say, a column like titanium, and then you can create a QQ plot based on attribute manager color groups. And you can see here what I've done is it's basically a QQ plot based on the attribute groups, attribute manager groupings. So that's for each of the sample method as we identified from the grouping itself. So say for example, if you have, so an application for this will be example, if you have your lab method in that column. So if your single assay column has data from multiple labs, basically you can select that in select variable and then use that categorical column as a color group in the attribute manager, and you can use that to attribute by color in the QQ plot option, QQ attribute plot. So that's with QQ plot. Anything to say with that, Dave?
No, but I think people comparing two different same element analyzed by different ways or in different medium will find it a very convenient shortcut.
Yep. So next up on the list is I'm going to show, let me just try to find the file, is some of our new analytics tool. So the first one I'm going to show is dbScan. So the dbScan tool is an alternative to k-means clustering. It works well with certain data distribution and certain data types. So it's just an alternative that we offer standalone under the clustering menu, and you can find that as an alternative clustering method for the self-organizing map output. So that's what it is. And in this data set, I'm just going to select some immobile elements. So just give me a sec. And another thing that we have added in this release is multivariate indicator. So that's the numbers inside the bracket here. And I thought I would show you that now because maybe some of you would have questions when you start looking at 7.3. And if you notice this number inside the bracket, you might wonder what it is. So it says here that you have 295 multivariate rows visible for the FELSIC A group. Okay, so what does that mean? That means the variables that you selected here, that I have selected just now in the select variables dialog, all my immobile elements, that means 295 out of 628 of the FELSIC A group, they have multivariate consistency within those rows. So that means if you're running a multivariate analysis tools like clustering or PC or anything like that, it will generate valid results for 295 of those rows. So just keep that in mind and that sort of thing.
So someone actually asked about that, Putra. So that was, someone was asking after seeing the first slide, what the multivariate meant, and that's what it means there. So it's just a warning that if you're plotting rocks from that group felsic A, given the element selection, you're only going to see 295 samples. I think that says.
Yeah, that's right. And it dynamically changes, right? So if I change this to say, like, I know, for example, that I think aluminium and calcium in this data set is pretty multivariate, so you don't get that bracket. So you can run all sorts of things with this 2 selection of elements. But if you go back to your immobiles, for example, it goes back to showing you that multivariate constraint indicator. So I was going to show the DB scan tool now. So I'm just going to run this on this immobile elements. So the dialog itself is pretty straightforward, and you will find more info in the help file. And there's a few options here, but I'll just whiz through them, real quickly. Unless you want to have something to say about the K and N distance plot, Dave. But I think we should be okay. So you can click on anywhere in the K nearest neighbor distance plot. But basically, what you want to look for here is where the gradient sort of changes to vertical. So I've looked at this data set before, and I know that epsilon around probably 7.6 is pretty good at getting the number of K that's optimal for this elements that I've selected and with the data rows that I'm looking at. And what I can do now is I can choose to apply that epsilon of 7.6 to the clusters and see how many groups I will generate. And then I can tick this button to create a discriminant projection plot based on the clustering of these elements. So this might be a bit of a mouthful, but you take those elements and then you cluster them, and then you use the clustered groups as input for discriminant projection analysis, and the resulting output sort of maximizes the separation between the clustered groups. So that's basically what it does if I click on this. And I'll show you what I mean in a bit once I have this generated. So these are the result of the clustering from the DB scan, and it generates a discriminant projection plot that maximizes the separation. And there's a good story here where I'll just create a new color group based on this clustering result. And basically what I can do now is I can, just give me a sec, I'm just going to create a filter group based on the DB scan. It's going to turn everything off except for the actual cluster groups. So basically, what are we trying to show here? So you have this DB scan tool that creates clusters based on your selected variables, and then you want to see how that sort of relates to your log geology. So I'm going to assign the shape based on log geology, and this is quite interesting. That what you can see here is felsic A, I believe, that's represented by the squares, that they are actually split into 2 separate clusters just by using the DB scan sort of algorithm. And you can sort of quantify how and what this means by using improvement to our new crosstab tool. So you see that I've already generated a new text column, categorical column based on the DB scan. So I'm going to select that, and I'm going to select our log geology column, and I'm going to bring up a, where do you find it, crosstab. And then once I bring up the crosstab, and if I bring up my statistics row percent of total column and that sort of thing, I can basically see what this means, right? So what I can tell is that felsic A can be split into 2 clusters mostly, and felsic B sort of corresponds to cluster 4, and mafic sort of corresponds to cluster 3. So you see sort of what I'm going with this is that you can automate sort of these boundaries just by using something as simple as this sort of tool, and using a crosstab to see sort of how accurate they are. So you compare the percentage within each column and percentage within each row. So that's a DB scan tool and how that fits into some of this workflow. Anything to add to this space? Okay.
Yeah, let's go. It's a variant of the appropriately named confusion matrix.
Yep. Yeah, that's right. And it's pretty useful workflow if you created your classification using something like our DB scan tool, the clustering analysis or self-organizing map, for example. And you compare the result of that with the groupings that you already know. So you classify them using unsupervised methods, and then you compare the results afterwards. And now I'm going to look at the recurrence plot and see what that means when you compare that with wavelet tessellation and other means of boundary detection. So I'm just going to open this file. And while that's loading, is there any other questions?
No, I don't think so, Pooja.
Okay. Okay, so I'm just gonna open this file, and what this file is it consists of downhole, gamma, and MXUS, and some geochem as well. But today we're just going to focus on just the gamma and magnetic susceptibility columns in this file. So I have these two selected, and I'm just going to create a recurrence plot based on this. But first of all, before we do that, let's try and see what it looks like in a downhole plot. So I'm just going to select this. So this is what this looks like in a downhole plot. And what I'm going to do now is I'm going to click on a recurrence plot tool. And then I'm going to choose the interval from and to. And I'm going to click on the numeric reverse. So this is quite important if you want to compare the result of the recurrence plot with downhole plot or wavelet tessellation tool. So important to have it selected to numeric reverse, so it actually displays the way we display the downhole plot. So you have 0 at the top instead of 0 at the bottom. So just one thing to keep in mind. And so just with this, I'm going to just run it, and the resulting recurrence plot can be used to delineate boundaries. I think I forgot to apply transformations. Sorry about that. So that's one reason why we'll need to use transformation. Do you have anything to say about that, Dave?
Yeah. So you must read the help file when using these methods, but the plot's based on calculating Euclidean distances. So therefore, the shape and scale of the input variables is really important. So you should always look at transforms before applying methods like this. Otherwise, you'll get nonsense results, or one variable that has a much greater range, absolute range, and another variable will completely dominate the maths.
Yeah, that's right. That's exactly what we see in the result. Before that, you can't really see the boundaries that well because you haven't applied any transformation to it. But once you do, and basically, yeah, this is what we see. Yeah, so that should be okay. And so you can see, the different warmer and cooler colors. This sort of indicates the boundaries, and it's pretty straightforward to look at. But it's by no means simple. But you can use this threshold to create quadrant scan sequence output, and you can use that to delineate the boundaries. So I have looked at this data set before, right? So I know what sort of threshold works with this file, and I believe I'm not gonna be brave enough to try it, but I'm just gonna let's try it here and click use threshold in plot. I'm just gonna see what it looks like. Okay, so if I choose to use threshold in plot, it basically filters out the plot for noise, and that will help us delineate boundaries better. So I guess one way that you can use this is you can click on this checkbox, and always read the help file before using this sort of tool. But basically, click this checkbox and just move the threshold button, and until you find a good boundary. So I guess maybe around here is a good spot. And if I create a column based on this, and then I'm going to plot the weighted quadrant scan result along with the gamma and MXUS, and put them in a downhole plot as well. So I'm still looking at the same drill hole. So putting them side by side. and you can see where it picks up, right? So it identifies boundaries. So there's obviously a boundary here, and there's a boundary here, there's a boundary here, and there's another group here. So you can see sort of like 3 or 4 geological boundaries here. And we can see how it compares with the result of something like Wavelet Tessellation tool. So I'm gonna select just the gamma. So you can see this sort of like a multivariate sort of boundary detection tool. But first, let's just select, to use gamma. So looking at single variate, and you can see the value of this once you compare multiple variables that you use in a tool like Recurrence Plot, and then you compare when you're looking at just one single variable in something like Wavelet, you can see the power of this sort of tool, because it picks up boundaries that you wouldn't see before. So in something like this, where you would be looking at just the gamma signal, it only identifies basically two chunks of data here based on the boundaries. So at this particular scale of say 13.2, it picks up only 2 groups. So if I make the scale the same, so if I resize it, so we're looking at same thing. So it only picks up this boundary here and here. Whereas if you use the recurrence plot, you'll see that it actually picks up three groupings here. So you have this, and this. So it's just one thing that you would use to compare, with using multiple variables in boundary detection tool. So that's just another option that we would use. And recurrence plot is still an experimental tool, so feel free to play around with it and see what results you can come with. But I would say that with recurrence plot and Wavelet as well, you would need to have really good data density. So if you're using it with downhole lithogeochemistry data with intervals where you don't have data and that sort of thing, it won't produce the result that you're after. So ideally, you would want something from our easy gamma tool, where you have data at very narrow intervals, and you have thousands of readings within a single hole, so you can pick up the boundaries more accurately, if that makes sense.
Hey, Putra, I've just got a question from someone who wants to know if there's a way to find what elements weight the clusters in dbScan. So when dbScan finds clusters, what elements are important in that? Yeah, it's a good question, actually. So it's not like an RQ-PCA, for example, where you get explanatory information about why samples plot in various parts of the plot. But what you would do is you would attribute the clusters using color and then go into the stats and look at the variation of the input elements by cluster, because it'll be multivariate in nature, so that's one way of doing it. Yeah.
Yep.
Or the other thing, that you do what Putra just did, and you take those clusters and put them into the discriminant projection analysis, and that gives you diagnostic information about what's pulling the clusters apart. That would be another way of doing it.
Yeah, so just with that workflow, Dave, I think so you've already created the clusters, but the discriminant projection plot was just a shortcut that I showed. But what you can do is you can take the color groups and use that as input with the same variables for a discriminant projection analysis anyway. So you can basically do the same thing and see which elements contribute the most to maximizing the separation between those groups and what control it has, and that sort of thing. So the last thing that I'm going to show, well, one of the last things.
One more question here, Putra, about the recurrence plot. Now, it's the question is, can you run the recurrence plot on multiple holes? But I think it's a hole by hole proposition.
Yeah, that's right. So it is indeed a hole by hole tool. So if you look in this dialog, you can only select one at a time, unfortunately. It's just the way it works.
Yep, that's it, Putra.
So I'm going to show one of the last features in this webinar, and that is the axial plane estimator tool. So with an emphasis on estimator, because it's just an estimation of the axial plane between the two hinges of a fold. So in this data set, for example, you have your stair net. So this is the same data set that I showed in the video. But it's basically, if you're looking at something like this, and you just want to see bedding 1 and bedding 2. So let's try and combine these two together. And now we're just looking at the poles. And then what you can do is you can click on the axial plane estimator. And then once you have that tool open, it allows you to select the limb. So it's automatically on by default. So this will allow you to select the first and the second limb of an axial plane. So I think I've only selected just some, but not all of the points in the hinge, but I've selected them all now. So what I did just then is, it tells this steer net to plot an axial plane that bisects the beta axis, and basically that's it. And you can choose to bisect acute angle or obtuse angle. And what you can do is you can choose to save this as a user plane, so you don't lose track of it after you save it, and you can reuse it later on. So for all of you people who use steer nets in gas, this is a pretty useful feature to add into your workflow, and something that's been requested before.
So I think that's it, Putra, yeah?
Yeah, that's pretty much it.
Yeah. Okay, so we're almost at the top of the hour, bottom of the half hour, whatever you want to call it. Our time is up, regardless. But look, thanks everyone for watching. And like I said, these videos will be made available, the whole webinar plus the short version that Putra showed earlier on. There's just one more thing, and that is that we are, for the next version of GAS, or the version after that, we're looking at ways to enable people to chain together various tools in GAS to create a workflow. And we would be very interested in talking to anyone who would like to tell us how they would use that. So just as an example, you might feed some data into a classification diagram, and if it falls into one field, then you want to take the samples in that field only and run that through another classification diagram, or a calculation for that matter, and then output an alteration index which is relevant to a particular protolith. Just things like that. We'd love to hear how you would use a tool like that, so that we build something that people are going to find useful. But yeah, at any time, just drop us an email, and we'd love to have a chat about that. So thanks for watching. Thanks, Putra, for running about 95% of it. Much appreciated. And Soph in the background there helping us out, and Shu controlling everything in the background. And we'll see you around the traps when we're all able to travel again. Adios.
Thanks, everyone.